So LineVision is a grid infrastructure company, but we're building grid infrastructure in a very new way that leverages sensors and analytics as opposed to the traditional approach of poles and wires. Um, what we're doing is helping utility customers unlock up to 40% additional capacity on their existing grid by using what's called dynamic line ratings. And this is super important because if we think about the energy transition, if we think about the need to decarbonize the grid, connect much more renewable capacity, but also the need to support new loads that come from electrifying transportation and heat pumps, we need a much bigger grid, and we need to build it quickly. The concept of dynamic line ratings has been around for more than 20 years, but earlier incarnations used load cells, used clamp-on sensors that were difficult for utilities to implement, and so it never really took off. The innovation that LineVision has introduced is twofold. One is that we have a patented non-contact sensor technology that actually mounts on the tower as opposed to on the wires itself, which has the big advantage that the utilities don't need to shut down power. They don't need to schedule an outage on those high voltage lines. But the other innovation is that we've approached this much more from a data perspective. We have a tremendous team of data scientists, of analysts, also physicists, who attack this problem with, I think, much greater rigor than has ever been done before. So if we think about some of the challenges that the grid faces today, number one, there's congestion on the grid, and you can almost use a traffic analogy. So this is cases where there's simply not enough transmission capacity to carry the power from where it's generated, wind farms, solar farms, to where it's needed, so the load centers or the cities. That costs us as a country and people who pay electric bills over $13 billion on an annualized basis. So that's over $100 per household in the US. The other problem is that new renewable generation projects cannot connect to the grid. They're stuck in what's called an interconnection queue, and the average wait time to connect a new solar or wind project is over 5 years right now. So our technology is going a long way towards alleviating those two immediate problems, reducing congestion on the grid, reducing the cost of congestion, as well as making it faster and cheaper for these renewable projects to connect to the grid. As we look to electrify things like our cars and heat pumps and how we heat our houses, we're becoming even more dependent on the grid. But we're also seeing more and more extreme weather, which is causing many times more significant outages on the grid, also wildfires. And so I think we're entering into a stage where many people who may have taken the grid for granted are no longer taking the grid for granted, which just drives the urgency of ensuring that we have a grid that is leveraging the best technology to be as efficient as possible, to expand capacity as much as possible, to be resilient, to be flexible. So estimates are that we will need to double grid capacity by 2035. So that's 12 short years to build as much grid capacity as we've built in the last 150 years, and then triple it, so build that much again by 2050. So this is a massive undertaking and will require building a lot of new lines, but also getting the most out of the grid that we already have. So I think what's important to know is that we don't need to continue to build the electric infrastructure, the grid, the way we have the last 100 years. I spent the early part of my career in the telecom industry and was fortunate enough to witness the transition from circuit switched networks to packet and internet networks, and all the creativity and value that unlocked. And I think we're at a similar period with the grid, where we can bring these new sensor technologies, these new digital technologies and AI and analytics to really transform the flexibility, the efficiency of the grid, and we have to. There's an imperative to address climate change and to get to a net zero grid, to really apply some urgency to deploying these important technologies.